Hi everyone, my name is Andrew Summers. Quick show of hands, who has never used Elixir before? Okay, a couple. How many people are kind of new to Elixir? Okay, how many people are maintaining a decently large Elixir application? Okay, that's a little mixture. All right, this talk is kind of going to be applicable to all of them for various different reasons, I guess. So yeah, let's go. All right, so my name is Andrew Summers. I'm a back-end software engineer at Albert.io. We make education software, tools for teachers and students. So it's a lot of fun. You should apply. We are hiring currently. I also wrote the Dialyzer Pretty Printer. So if you've ever used Dialyzer and the error messages suddenly got way better, that was me. I maintain that project. I'm also maintaining the Elixir language service protocol fork now with a few others. Come talk to us in Slack. There's a language server room. We would love anybody to contribute to any of the various off branches of that. And then, most importantly, I'm not a gardener. So despite the name of the talk, do not take this as horticultural advice. So what is this? It's a lot of opinionated patterns that I've kind of learned from writing and rewriting a lot of Elixir code, just various points of confusion that people have come up with just by doing various things, resulting in fixing tricky bugs. And a lot of it is my particular taste, so you might disagree, and I hope that that can actually become a conversation point when we get to questions. So take note of any of those. So when you begin an application, you start with a seed. You have to have your idea. You got to put it in the ground, and you actually have to start somewhere. There's no, you just got to get some code out there, and then you got to just go with it. You got to give it water. You got to just let it accumulate some nourishment, and it needs to just grow a little bit. So if you have a pretty simple application, that might be all that you have to do. Don't over-engineer things if you don't have to. And the ideal goal is that you don't actually have to take most of this advice into account. But for some of us who maintain larger applications, there becomes a point where you actually have to start paying attention to some of these things. So at the end of the day, what you're trying to do is you're trying to control the growth of your application. You're trying to control where and when the modules can grow, what they're pointing to. And when you go and refactor code in particular, you want to make the compiler be able to help you. You want to be able to lean into the tooling that Elixir and Erlang provide, and be able to just let it tell you when you did something wrong. There's a really good blog post that Jose Valim, the creator of Elixir, wrote about writing assertive code. I highly recommend reading this. I'm not going to go into all of the things that he went into, but it's a very good article. And don't worry about writing that link down. I'll post the slides as well. But it's about just techniques that you can do to write more assertive code. Because when you write more assertive code, bugs are harder to sneak by. So in the Lisp community, and I'm not going to necessarily go into this talk, but I think that Elixir is very Lisp inspired. But in the Lisp community, there is a mantra that data is greater than code, is greater than macros. We have all of these things, and to kind of, I think that that is true in Elixir as well. And to kind of illustrate that point, I would actually put a double greater than there. I think that data structures are really the key to everything. If you can put your logic into a data, you can often ask it questions about itself and do some really cool things with it that you couldn't do if you were encoding that logic in either a function or a macro. So one thing that you can do is you can put stuff in structs. So structs are very useful. They basically let you name maps. It's not exactly what they are, but you can think of it that way. So I might have a person struct, and that might have a first name and a last name and an email. And if there's one thing that I've kind of realized in refactoring a lot of code is that impromptu data structures where you really want something that's more structured, if you don't have it, you're often fighting against the tooling. So if you find yourself passing around what I call a naked data structure, consider making it a struct. I think that it's most useful at the ingress and egress boundaries of either your entire application or the subsystems within your application. But I think passing around your data in a structured or semi-structured form is just very helpful. One technique that you can do is you can match on the struct name, and then if your struct has a bunch of functions, you can grab the struct and then you can just grab the module name and invoke functions on it. We do that a lot in our code at work. But if there's one thing that I would caution when you're creating structs is not to create them too early. Let the patterns kind of emerge within your code before you go and just give something a name. Because when you create a struct, you are creating rigidity within your application, and if you're not at the point where that rigidity is useful and your program is still kind of evolving and it's still kind of taking form and taking shape, then adding that kind of rigidity too early is often more hurtful than it is helpful. So if you're questioning whether or not you should create one, I would definitely say don't create one too early. It'll be clear when you should be doing it. You'll wind up having these repeated structures all over the place, and it'll be very clear that you need some sort of name to put to that thing. I would say that if you're coming to Elixir from an object-oriented background, you like classes. You know, Java has classes, C++ has classes, all the other languages have classes in some capacity. And often what you will wind up doing is creating structs for everything because it feels very natural. Don't do that. Resist that urge if at all possible. One of the nice things about Elixir is that you don't really need to have your data be structured to access things about it and access portions of the maps that you're passing around. And your inclination will be to do that. I did the exact same thing when I first started in Elixir. I've regretted it in some capacity in a few places. So behaviors, I think, are one of my favorite features of the language. How they originated in Erlang was around formalizing the GenServer concept. We'll get to GenServer later, but there's a concept in OTP called a GenServer, and what they found is that you had all these callbacks, is what they call them. So Erlang, starting out with the telecom, you would actually make calls, and so you would have a lot of functions that said handle call or handle cast for synchronous and asynchronous messages, and so they wanted to give you some rigidity around grouping all of those like functions together. If you're unfamiliar with the Elixir Cockburn ports and adapter pattern, I think that it applies to how I use behaviors in my own code, where you have this generic port and then you have this adapter that meets the specification of that port. Think of you know, if I'm hooking up some hosing to something, you have the adapters at the end, and the adapters let you, because they're all the same on either side, you can create the fittings to fit that adapter. So I think of behaviors in that kind of light. Elixir 1.5, I believe, it may have been 1.6, they added this tag above your functions that you can put at impl. And what you can do is you can say at impl my behavior, and if your behavior does not have that callback in it, so say you have a behavior that defines a callback foo, and I say that I have a function bar, and I put at impl my behavior above it, because bar is not in that behavior, it'll yell at you. And similarly, if you get the function arity wrong or any class of errors around that, it will yell at you, and you'll get a compiler warning. If you treat your compiler warnings as errors, which I highly encourage you to do. It will just prevent a whole class of bugs. Because what will happen is when your program goes to invoke that function, it's not actually there, and bad things will happen, and your program will blow up. And nobody wants that. I would encourage you to be explicit about your impl tags, however. There's a shorthand that is occasionally useful. You can say @impl true, and what it'll do is it'll find all the behaviors that your module implements, and it'll find the one that it corresponds to. I find that that's really bad for documentation and for just trying to find where this thing is coming from. Because say I want to know, I'm looking at a function and I need to figure out why is this function here. I see @impl true. I then have to scroll to the top. I have to figure out all the behaviors that my program implemented. And it's just an unnecessary layer of indirection. If you have the same callback for multiple behaviors, you have to use the @impl true. That's the only way to get around that. But most of the time I find that to not actually be true in real life code. So I would encourage you to just be explicit about the behavior that you're implementing. There's also a mocking library that the Platform Tech people wrote called mocks. And when you're mocking a service, you have to have a behavior for your service. That's just how mocks works. And so if you're using that library, you're going to be having behaviors all over the place for the various services that you're mocking anyway. And I just find that having the behavior around the modules that you're passing around and knowing what functions are going to be there by them implementing that behavior, it's really useful for when you're creating generic pipelines. So one pattern that I don't really see too often in code in the wild, and we rather like it at work, is modules as data structures. So if you have a struct, that's the common data structure that you can pass around, and it's got some fields and some data that you shove into it. But what you can also do is just encode that data into functions at compile time. And given that we're in functional languages, the difference between functions and data is not very, very large. But in combination with using behaviors, I find that it's a really powerful pattern to just make a module, just give it a bunch of functions that are all behaviorized, and just throw the data into the functions themselves. If you look in Ecto, they have an underscore schema function, and you can say like, what are your fields, what are your associations? And I rather like that pattern, because what you can do is you can just ask the module about itself. You can ask it about the data that's contained therein, and I don't know, it's a useful pattern. It's not always applicable, but there are probably cases in your code where you could use something like that. Yeah. So when you pass when you have a generic pipeline in your application, I'm thinking more in like the domain-specific language sense. You often have these very, very generic pipelines, and being able to ask modules about themselves and just say like, hey, what are your fields? What are your associations? You can do a lot of really powerful things in combination with metaprogramming. Cool. So def protocol, truthfully, I don't really use this too often, and when I was preparing my talk, I actually had some kind of insight as to why I don't use this. I think it's extraordinarily useful if you don't control both sides of the data structure and the pipeline that's operating on the data structure. It's very similar to Swift protocols and closure protocols, if you've ever used any of those. But what you can do is you can extend the existing behavior of modules that you may or may not control, and if you have your own module, you can establish it to be able to hook into somebody else's pipeline. And as an example of this, in Elixir, there is the enumerable and inspect protocols. So what you can do is you can say, I have my special customer object, and you can say, you can implement the inspect, and using some of the new Elixir 1.8 features, you can tell it to just ignore fields in there, and it'll redact those fields if they're sensitive, for example. So if you have a password in your user struct, you can tell it to just align that field in the inspect. And even though Elixir has no idea about your special customer struct, you can hook it into that pipeline, and when it goes to invoke inspect on that thing, it knows exactly what to do because you told it what to do by implementing the protocol for it. If you control both sides of the pipeline and all the data structures that are ever going to be into it, and you think that you're going to do that forever, I don't find that protocols are that useful, but I could just be using them wrong. Bamboo is another place where the emailer, it uses protocols, so you can say, I think it's like bamboo.format or something. You just hook it in and it'll say like, oh, this is the person to whom I'm going to address this email to. Interrobang. So when you write functions in Elixir, you can actually put punctuation in them, shockingly. This is true in a lot of lists as well, but in Elixir, what you can do is you can mark a function as returning a boolean, and you put a question mark after it to indicate that this is going to return a boolean. And you can also do that in variable names. And I find that that's really helpful when you're just quickly glancing at code and just reading it and trying to figure out what's going on, to just have that little bit of insight from the syntax to be able to tell you that. And similarly, if you put a bang next to the function, it's idiomatic for that to be a function that raises some sort of exception. Raising exceptions is often not idiomatic within Elixir, but there are definitely cases where you need to do so. And just signifying that in the function name tells the caller that they should be prepared for this thing to raise an exception in some capacity. But if you do that, please provide a function that does not raise, and it returns the OK error tuples. Often what you'll see is that the OK error tuple will just call it, or sorry, the bang function will call into the OK error tuple version, and if it ever gets the error case, it'll just raise an exception. That's usually the pattern that you see across the standard library. Dependencies. I don't know how many people saw Gary Bernhardt's fun tweet the last couple of days, but he's been doing some React stuff. And so he did the create React application and found that there is 1,567 dependencies and 1.2 million lines of code for something that's effectively a hello world. We don't need that in Elixir. Please don't do that. Try and minimize your dependencies wherever possible. But don't invent them. Don't reinvent them if you don't have to. If there is a dependency that does what you need it to do, just use it. But just recognize that you are bringing code into your application that you are eventually going to have to maintain. You have to evaluate it for security risks, and then if they're, if the maintainer leaves or anything along those lines, you just have to deal with the fallout of that. There's a lot of abandoned GitHub repos out there, and the more dependencies you use, the higher likelihood that you'll wind up in that spot. And so it's just like it's just good risk assessment to just try to minimize your dependency footprint. And when you have dependencies that are semi-useful, it's often a good idea to just wrap them, because then you can swap out the interface to whatever it is that you actually need to get out of it, and it gives you more guidance about what to do when something changes. And the harder, the deeper that the dependency reaches into your application, the harder it is to deal with inevitable changes. As an example, Ecto 3 just changed the way that they do filtering association. So what you used to be able to do is you used to be able to give a relationship a where clause, and you used to be able to give it a function pointer and say this is where the query for this where clause is coming from, and they changed that. And so over the last month or so, I've been having to deal with the ramifications of that change. It's a good change. I understand why they did it, but because we lean into Ecto so much, it was a pain to do that. And we particularly leaned into that feature a bit. And so ripping that out was just, it was painful. It was more painful than it probably should have been. And I think had we been a little bit more diligent in how that was all laid out, might have gone different, and that made it a bit easier. So let's talk about call paths. Don't do this with your call paths. This is not the shape of your application that you inevitably want. You want to maintain good root structure around your application, is what I'm calling this. There's a tool called mixxref. So what you can do is you can say mixxref, and you can give it a source or a sink, and say like, what are all the functions or what are all the modules and functions that are calling into this particular sink, and then what are all the functions that my source is calling to do the opposite direction. And looking at your application as a whole in that tool will kind of give you a good idea if you actually do have that tree shape that I just showed. I won't judge, I promise. But it's just not a good idea to have these crisscrossing lines that interleave with each other. I find that utility modules are really useful for leaf classes and leaf modules. Just when it's the end of the line and the only thing that they're calling into is the standard library. I find that shoving those into some sort of util or helper class is good. That can obviously be abused. Having 1,000 modules across your application called util, or similarly having a junk drawer where you shove all the util functions. That's often not what you want, so treat that with a grain of salt. But I find that there are definitely places where you just want to just shove a bunch of functions away and just put it in a drawer and kind of just forget about it. And I think that keeping the directions pointing down is really good. Where like if you're calling a function, having it not have to reach back up the tree just leads to easier refactoring down the road, because then you can just chop off one of the branches and not worry about how it's going to affect things. And similar granularity layers should call each other. So you shouldn't be reaching down to really base util classes really high in your application, and you shouldn't have util classes reaching into just crazy areas that they otherwise should not even know exist. So just keeping the layers of interaction at the same level, I find is a good idea. There's a book called Philosophy of Software Design that I'm in the middle of reading right now, and it has a concept called deep modules. I don't agree with everything in this book, but I find that particular construct is pretty good. Having a small interface at the top that inevitably calls into some really rich code. So as an example, you can think of Ecto. Ecto has a couple main modules that you interact with. You have the schema and the query module and the repo module, I guess. And besides those three, you often aren't interacting with things. But if you go and you look at the Ecto code, it calls into all sorts of crazy private modules and just undocumented functions that they're trying to hide from you because they have a very deep call stack. When you're debugging, that's not always the best. So if your application matures or is maturing, it's not always the best idea to just do that immediately. But as it sorts to start to take shape, I find that it's good to have these smaller interfaces at the top that call into more complex behavior. So I use Emacs. I'm an Emacs guy, and so I don't really have all the VS Code IDE fanciness, and so I grep a lot. And so what I like to do is optimize my code for greppability. In particular, your file name should always match your module name. There's probably a lint rule that should exist around that. Somebody should definitely open a PR around that to assert that the file name is the camel case version of the module name. But I find that making sure that those match is often helpful when somebody is traversing the code base, either in in the directory explorer or just poking around and trying to figure out, well, where is this module? It's called x.y.z. Why is it in w.x whatever, some other place where it shouldn't be. I don't like partial aliases. I find that they make code harder to read, and so what I mean by that is if I have some function a.b.c, what you can do is you can say alias a.b and then alias b.c, and I find that that makes grepping in trying to figure out where code is coming from very, very, very difficult. So instead what I prefer to do is to explicitly say alias a.b and then alias a.b.c. And just explicitly lay that out at the top of the file. When I'm trying to find all of the uses of a.b.c, it'll take me to that file, to the alias, and then I can just look for all the uses in that file. And similarly, multi-aliases have the same problem. They're effectively a special case of the same thing. You can, if I have a.b.c and a.b.d, what I can do is I can say a.b, alias a.b, and then give it a curly braces and say C and D inside of the curly braces, and that's just really a special case of the same problem. It makes it harder to find the full use of that. I find that aliasing is often what you want to do as a reader of the code. As a writer of the code, not having to explicitly call out the module every time that you want to call a function is great because I just have this in my namespace. But somebody that's reading the code comes in and goes, okay, well, where is this function coming from? And then, especially if you use something like macros, it's often very hard to actually figure out where this function is coming from. It just kind of showed up in your namespace and you have no idea where. And if you do have to use import, there's a thing that you can do called import only. So you can give it the function and the arity that you're importing. And I find that if you do have to import, that doing that is more helpful than just importing the entire namespace. And if you don't use a function, that's actually more helpful, and it'll tell you that you're not using one of the functions that you've imported. So the compiler can actually just give you a little bit of a hint, and that often leads you to be able to find some dead code that you have in your application somewhere. And try not to import stuff in macros. And if you do import stuff in macros, you can unimport things. I didn't list that here, but you can, in the same way that you can import the functions, you can say import only, and then you can give it an empty list. And what that'll do is that'll actually unimport all the functions from that namespace that you've imported. And I find that that's very helpful in not polluting the caller's namespace. Just having a whole bunch of functions show up and just be in your namespace just isn't usually what you want. Sometimes it is, but not always. Cool. Macros. Macros are awesome. I love macros. But that doesn't mean that you should use them everywhere. In particular, you shouldn't do serious work in macros. You should do only as much work as is necessary to actually do your job in the macro that you otherwise could not do in a function. And as soon as you can, you should delegate out to a function. One idiom that we have in our code is that if we have some macro foo, what we'll often have is we'll have an underscore underscore foo underscore underscore function, and the macro will grab its namespace or grab the parameters, unquote them, and just delegate out to that function as soon as possible. I find that that's very helpful for debuggability because you don't get very good error messages when something bad happens in a macro. Sometimes it'll even just hang, which usually isn't what you want. But if you're in a function, the error messages are much better. It can tell you where something happened, why something happened, in a much stronger sense. Location keep is also a really cool thing. So inside of a macro, you can say, quote do whatever, my macro stuff. But if you put location keep between the quote and the do, it'll keep the place where it was called from the caller. So a macro, what it's effectively doing is it's taking all this unquoted stuff and it's putting it into your module where you called it. And if you don't have location keep, say you have like your macro unfolds to 100 lines of code, all of your line numbers below where you called it are going to be off by 100 lines. And so when you do location keep, what that's actually going to do is it's going to keep the line numbers from the calling code, and that's usually what you want. I'm actually not sure where I wouldn't want that. That's actually an interesting question, but I generally use location keep everywhere, and I submit PRs to upstream code bases all the time when I just notice that a line number is just weirdly off. Just add that. After compile is a fun thing. You can before the module is, or I guess after the module is compiled, after all the macros have done their job, you can give it an after compile hook and do validation on it. I find that that's really useful in things like DSLs because after all the dust settles, you've created all these modules, you've created all these functions, you have these data structures hanging around, and being able to ask those things questions about themselves and assert that the thing that you're building is what you wanted and doesn't have some weird some weird validation that it violated. That's usually where I wind up doing that. So lexical tracker is an interesting concept. In Active, for example, say I have a user schema, and I have an addresses schema that are all represented by tables. In my users table, I might say that the user has many addresses, and in the addresses table, I might say that addresses has many users. But since they both require each other to be able to compile, which do you actually compile first? You get a compiler deadlock there, and so by disabling the lexical tracker, you can tell Elixir that you basically know what you're doing and that it doesn't need to keep track of that because you're going to make sure that you're making sure that everything's going to compile appropriately. Don't abuse that. Please don't abuse that. It's very ripe for abuse. But when you need it, it's exactly what you need. And you can look in the Ecto source code to find an example of that. Also in macros, avoid name generation. If you have a name for a module somewhere, I should be able to find that somewhere in your code. It shouldn't just come out of the ether. You shouldn't be concatenating parts of classes or concatenating parts of strings and converting them to modules and atoms. And I've seen some really bad stuff. There are some web frameworks that we use in Elixir that occasionally do some dirty things, but usually you don't have to do that. Usually you can get away with just giving it the whole name and saying like this is where this is coming from. And when somebody needs to go and debug that, like if there's a function that's coming from that module, just being able to find where that's coming from and not having to hunt down like where this thing got concatenated together in some macro somewhere, it just makes your readers of your code much happier. And clean up after yourself. Like I was saying before, you can unimport things. Just don't leave a bunch of stuff hanging around, because again, you're literally taking these unquoted blocks and you're shoving it into the person's module. Be a good citizen and only put the stuff there that you actually need to. Don't bring around a bunch of extra things that you don't need. Dialyzer. So like I said before, I wrote the Dialyzer pretty printer, so I'm a little biased in this regard. But at-spec all the things. Even if you don't run Dialyzer in your code, it's really useful to the readers of your code to get the author's intent of what sorts of function parameters you were intending to give this function and what you expected this function to return. I encourage you to use Dialyzer, but even if you don't, just having it be a documentation tool I think is better than nothing. And when, as your code base starts to mature, you'll eventually want to run Dialyzer, and starting from somewhere is often better than starting from nowhere. You can, there's a Credo rule that you can use that enforces spec on all public functions. It's very easily adaptable to private functions as well. Just where it says def, also just make it say def p. It's really straightforward to do. And I encourage you to turn that rule on. It's an optional rule. It's not on by default, even under the strict mode. So you have to enable it separately. But I encourage you to turn that on. It's usually what you want, especially if you maintain a library. If you maintain a library and you don't run Dialyzer, your users will inevitably wind up hating you at some point because you're just going to have something wrong with your code that they have to then go and fix, and they can't upgrade to your dependency for whatever reason. And if you're on vacation, then they can't upgrade because they potentially have some sort of security vulnerability. It's not great. So if you maintain a library, public library, please use Dialyzer, and please use @specs on all your functions. There's one thing that I would say is to wait for pain points. Don't over-engineer things. Keep an eye out for abstractions that you want to exist that are solving some problem, but make sure that it's actually a problem first. We have a lot of really cool ways of metaprogramming in Elixir, and you can get yourself into trouble by over-engineering things. So wait until something becomes a problem and then do it. There's a really good Sandy Metz article. She's more in the Ruby community, but she has an article called The Wrong Abstraction. And the TLDR of that article is that the wrong abstraction is significantly more expensive than just having a little bit of code duplication. There's the rule of 3 to say create some sort of abstraction when you see something 3 times. I would even go a little bit past that and say that that's probably more like 4 or 5. You'll know when you need some sort of abstraction because you're just going to be repeating yourself all over. Aggressively refactor. I love refactoring. Refactoring is probably my favorite thing to do as a developer. But refactoring for clarity is really what you want to be doing. Most of the time Elixir is fast enough, so you're not going to be refactoring something to make it a little bit faster most of the time. But naming things and pulling things out to functions is often really, really conducive to figuring out the actual shape of your application. Usually your first and second iteration at some thing that you're doing is not going to be the clearest, but going in and just constantly looking for ways to refactor it to make it so that your teammates can read it, or even you can read it when you go back and you need to debug the code that you wrote 6 months ago. Just refactoring that for clarity is really it's a good idea. And be on the lookout for unused functions. We don't get a lot of help from the Elixir compiler around unused functions. Like I said, you do get it if you import something that you're no longer using. If you have a defp function, a private function, it'll give warnings when something's unused. And similarly, defps can also be inlined. But keep an eye out for unused functions. I would say that if during a course of a pull request somebody stops using a function, just take a look around and see what the other callers of that function are, and that's usually when you're going to want to do that, because, like I said, you're really not going to get that much help from the compiler. And just constantly be reevaluating for unnecessary abstractions. Like I was saying, the wrong abstraction is bad, and if you let it around long enough, it can fester into something that you're going to be punting this problem down the road. Just keep an eye out. You don't need to solve every incorrect abstraction immediately, but just take note of it. Take note of when something feels awkward. Take note of when something feels kind of forced and unnecessary. And just keep it in the back of your mind. Throw it on your bug tracker somewhere. And yeah, just reevaluate often. GenServers and Umbrellas. So OTP has a fun concept of GenServers, and there's a really good article from, who wrote this? This is Freddie Bear, I think. He wrote the article Spawn or Not, and effectively it talks about what it would look like if you modeled Blackjack as inside of a GenServer. And he talks about why somebody would arrive at this and what would motivate them to do so, and then goes into a whole laundry list of reasons why this is a bad idea. I've done this before. I've tried to model process state in my applications, in processes and GenServers, and it's usually not what you want. They and Umbrella applications are more for more for runtime concerns rather than code organization. That's not to say that you can't use them as that. So I would say that if you're, one thing that we're doing is we've been trying to pull our framework that sits on top of Phoenix out to a separate Umbrella application, and using an Umbrella as an intermediate step to pulling it out to a separate repo. That does work, but you can get into trouble. As an example, what you can do is, because if you have some module that is available in your parent application, I guess, the Umbrella application won't give you a compiler error that you're using that module because it's available in its namespace somewhere, until you go down actually into the apps directory for that individual application and try and compile it. Then it'll yell at you and say like, hey, I don't know about this random module from your parent application because I don't have access to it in my namespace. But your code will run. It'll run. It'll do everything that you want. So just be kind of wary of that. And if you're on the fence about it, I would say to just pull it out to a separate application, because then you just don't have to deal with any of those problems. I'm sorry, to a separate repo, because then you don't have to deal with any of those problems. That's all I got. Is there any questions that anybody has? Yes?
Great talk.
Thank you.
One of the problems that we have in our app is sort of knowing, I guess, how to respond to failure. And so crashing is useful a lot of the time, but a lot of the time it's not what you want also.
Yeah.
So what kind of experience have you had around when in specific situations you'll assert against an OK value or an error, or when you'll do a try and rescue, or when you'll do a try and fail, or when you'll just assert against the results and let it crash regardless? Sure.
So I would definitely encourage you to read the defensive code article. That doesn't exactly cover this question, but in the spirit of OTP, usually the place where the crash is occurring is not the place that is most knowledgeable about what to do in response to that crash. And so whether that's in the context of a GenServer where some worker process is crashing and the GenServer supervisor needs to respond to it, usually something a little bit higher than where that's at is going to need to respond to it. But you should respond to it as close to the source of the error as you conceivably can that doesn't feel awkward. That's not a real answer to that question, but that's kind of just like my general ethos on what to do with that. I try and insert, like when something should be returning an OK or error and I can't reasonably do anything when there's an error, I often will just defensively code that and just say like, OK, blah, 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 blah. And when it crashes, that might just be some sort of catastrophic failure. And then if I have some higher error handler that can then pick that up, whether that's in the context of Phoenix, and I can return some 400 or something along those lines, that's sort of my advice on that. Any more questions? Yes?
Going back to the beginning, we talked about structs.
Yeah.
How do you feel about giving the users of structs access into the internals versus running a bunch of functions in the module that know how to pull data out of the structs?
Sure. So repeating the question for the camera, the question was whether or not to use access functions in the module or to just let the users just poke at the fields directly. I think that's kind of dependent on what's going on. As one example, if I have a plug and I'm setting, if I'm setting the assigns, if I'm assigning something to a plug, I'll often put a getter and a setter inside the plug logic itself. And not have the users of that plug just have to poke around at the conduct assigns. Sometimes you need to do that though. Sometimes you really do need to there are particulars in your application where you really do just need to, set turn halted from false to true and just pass it along. I would try it at first with putting it in the functions, and then once it feels kind of awkward, to just figure out why it feels awkward. You might have some missing abstraction there that will clarify that. I don't like poking around at data often. I like if I know what it's going to be, I will read from it and not do some sort of like accessor. But if I'm setting something, I usually want to leave the I'll usually want to have a module do the setting of that thing, because it can do whatever validation it needs to there, and especially if you need to do some validation, you should defer that to a function.
Thank you.
Yes, anybody else? Cool.
Thanks,